Today we're going to be hardwiring an inverter into a normal everyday vehicle like this one here. But not only this, we're going to be talking about wire sizing and how to calculate that. We're going to be crimping connectors, talking about the firewall and how to route cable, and also protect the cable from potential shorts. So without further ado, let's get going. So you may notice your inverter included some crocodile clips like this. More on that later, but why can't we just connect this to the cigarette socket? So this cigarette adapter socket here, or auxiliary power outlet if you want to be fancy about it, is generally protected by a 10 or maybe a 20 amp fuse. And when the car is resting at 12 point something volts, or the car's running at 14.6 give or take volts, then it's calculated that this socket will give between 120 and 240 watts of power. So if you introduce a 1500 watt inverter, a 2000 watt inverter, even a 1000 watt inverter, then you're going to have some issues with this. The inverter will probably work just fine, but when you put a load on there that demands more than the amps of the fuse, then the fuse is just going to blow. So then you may ask another question, well, why can't we just hardwire the inverter into our fuse box right here? I seem to have done this with the car stereo. Check out that video, link it below. Why can't we just insert our inverter here using a fuse tap into an existing circuit? There's nothing wrong with that, right? Well, the thing is, these fuse boxes aren't really designed for heavy loads like 1000, 1500 watt inverters, because the wiring just is a very high gauge right here. If you're talking about a 2000 watt inverter, then this is the wire you're sort of looking at. And if you bring this to the fuse box, you can see instantly there's something a little off here. The internal wiring behind the fuses here, you can see how thin it is. And if we run such a high current through these wires, they're going to heat up like a glowworm, and then you're going to cause a potential fire. So with something like an inverter that uses a large amount of currents, which requires a thicker wire to cater for this current, then we're going to have to hardwire this to the battery directly. And usually we go through the firewall, which is this big section here separating us from the engine itself. And that's what we're going to be doing in this video. Okay, so back on the topic of these alligator clips, what the hell are these for? Well, two reasons. The manufacturer just going to give you these so you can hook it up to a car battery when you go camping. You can plug in your phone and be away with it. They're impossibly short, they're not realistic. You're not going to use these when mounting this in a vehicle. So this is why in this video we're going to be using our own wiring. We can control the gauge of wire, make them thicker for certain reasons, because the longer the cable, the more voltage drop you will experience. And to cater for this, you're going to need a slightly thicker cable. So if this is mounted in the trunk of your car, you're going to need a longer wire and therefore a thicker wire to cater for this. More on this later in the video. The second reason, copper is expensive. These typically have a copper conductor. It could be aluminum, but these are copper. Copper is expensive. The manufacturer's not going to give you really long meaty cables. They're going to cheap out where possible. So now that we've touched on voltage drop and wiring, let's get over to the whiteboard and start sizing our cables. Okay, so we're on the whiteboard really quickly. I'm just going to talk about how to gauge the size of wire. What size wire do you need? How thick should your wire be, depending on the size alternator you have, the size inverter you have, and everything else. Well, what's going on here? How do we work this out? Well, let's talk about it real quick. So when your car is running, you have your alternator here charging the battery on your car. Now, if you have a very tiny car like this one here, and you plug a 5000 watt inverter into here, then it's probably not going to supply the power required for your inverter. That's just how it is. In our example here, we have a very small car, but we're going to be using a 1500 watt inverter, and this is going to run just fine on our vehicle. So what size wire do we need in this instance for a 1500 watt inverter? If we use a very skinny wire like this one here, and we pass too much current through here, then this is going to heat up, the insulation's going to start melting, we can cause a fire, and all kinds of things. We don't want this. So the thicker the wire, the more current it can handle. And if your wire is really long, then you're going to suffer something called voltage drop. So the longer your wire, the more voltage drop you're going to have. And in order to combat that, we're going to need to make this wire slightly thicker to cater for voltage drop. So all of this is very important when sizing wire for the electrical circuit for your inverter. So let's talk about how we can calculate this real quick with just some quick examples. Okay, so let's run an example real quick. There are actually online calculators you can plug amps, volts, watts, and everything into, and it will tell you exactly what size your wire needs to be, what gauge your wire needs to be. It's very simple, but we do need to know a few things first. Now, what is the voltage of our system, right? Well, we're talking about cars, right? It's a 12-volt system. Everyone knows that. Well, that's what people say, but when you actually go out there with a multimeter and measure it, it's more like 12.6 volts. Okay, if you want to be very accurate about this. However, when you start your car, you go for a drive and measure it while the car is running, you'll actually notice maybe it creeps up to something like more like 14.6. So this is what everyone talks about informally. This is when your car's in the driveway and it's not on, and this is while your car is running. So there's two voltages here, more on that in a second. Our inverter is a 1500 watt inverter. If your inverter is more, then put your figure in here. If you're running a truck and it's 24 volts, put your voltage in there. Same principles will apply. So to work out the amps of our system, very easy. It's a quick calculation. We take our wattage, in this case it's 1500 right here, and we divide it by the voltage, so divide it by 12.6. I don't know what that is offhand. It's around 120 amps, give or take. You can work it out. And we'll take our wattage and divide it by when the car is actually running, which is 14.6, and we roughly get around 103 amps. So when plugging these details into an online calculator and working out the gauge of wire you need, whether it's a skinny wire or a thick wire like this one here, you're going to need your voltage. You're going to need the wattage, amps, and also the length of the cable. More in a second on the length of the cable. But which one of these are you going to use? Am I going to plug in my 120 amps or am I going to plug in my 103 amps? Well, the thing is, you want to use the worst case draw. So we don't really want to size our wire for 14.6 volts when the car is moving, because that's not the worst case draw. If anything, we should use 12.6 or maybe even a lower voltage. Say our car battery is dying, it dips down to maybe 12 volts, 12.1 volts or something like that. That would be the worst case draw in this case. So out of these options, we should really home towards the 120 amps, but it could potentially be more than this if our battery is dying. So the final thing we need to know is the length of cable required so we can finally get the gauge of wire we need. So therefore we need to decide where we're going to mount this in our vehicle. So where are we going to put this? If we put it in the trunk, we're going to need to spend more on cable, but it might be more convenient for us. For me, I'm going to mount it under the dash, and there's two reasons for that. One, I really want the sockets there. That's just where I want them. And number two, our cables are going to be almost the shortest distance possible. Our car battery is right there, and that's where we're going to hook up to, and almost less than a meter away, less than 3 feet away, is going to be our inverter. So I'm going to save money on cable, I get my perfect mounting position, and everything is happy with that. So for me, it's going to be 1 meter or 3 feet. That's the length of cable we're going to need for this inverter. Okay, so these are the figures we're going to be plugging into our calculator here. We're going to be using a copper conductor. So this is the conductor inside the wire insulation. We're going to be using a copper conductor here. Copper is better than aluminum. The choice is yours. If you use aluminum, just like voltage drop, you're going to have to increase the gauge of your wire to cater for the aluminum conductor. So we're going to be using copper. Copper's great. And lastly, the length of the wire, it's around 1.5 meters, which is in American units around 4.5 feet. With all of this information here, we can calculate the gauge of our wire using an online calculator. Okay, I want to talk about the wire sizing. Now this will help you in any project in the future, so just Stay tuned for a couple of minutes. It's going to teach you so many things you never thought were possible. So let's take a look. Let's put our figures in for a start. Well, now we said the amps would be higher when the car is in the driveway. The car's not running. That's 12.6 volts. That's a worst case scenario, which calculated our current amps as 120. We calculated that our wire length was 1.5 meters or 4.5 feet, depending which measurement system you use. Include return. Now, electrical items have an electrical path. We can't just go one way. We've got to get back to the source again. So we can do 3 meters for the whole path and toggle this, or we can put it back at 1.5 and include a return. This is just how it works. We click calculate. And this is the gauge of wire. Now this is the minimum gauge we need. We cannot go thinner than this. So if you want to save money, you're on a budget, you want to save money on expensive copper conductors, then this is the minimum you need. There is no harm going up. You can go thicker, you can go as thick as you want essentially. You can go AWG0, it's thicker, no problem at all. But this is the minimum. If you go thinner than this, it's going to heat up and potentially cause unsafe situations. Now, when I said worst case scenario, what if our battery is dying? It no longer can supply, say, 12.6 volts of power, or maybe our alternator is dying, something is dying and we cannot get a 12.6 constant voltage. Let's use 12. This is a perfect worst case scenario. And you can see the wire is just the same. It still satisfies the condition. Say somehow miraculously our battery is completely dead, but magically the car starts. You can see how the gauge goes up, it increases. So this is what I'm talking about when I talk about a worst case scenario. Always plan for the worst case scenario. Then if your inverter spikes, then a fuse won't trip. Your wires won't heat up and glow. This is what we talk about when we talk about worst case scenario and safety margins as well. There's other calculators you can use. This one's way more complex, but essentially it gives you the same information. If we click calculate here, you can see it gives us the same results here, but it gives us some information based on various other things as well. It's a little overwhelming, but it gives you more detail on the thickness of the wire or gauge of wire you need for this project. So I hope that makes sense. Let's get back to it. Okay, so now all the theory is out of the way. You are now a wiring expert, no problem, right? So the first thing we need to look at before crimping any connectors, putting fuses on anything, is how to get our wire from the battery, and we'll talk about that in a second, why the battery and not the alternator, to the passenger compartment or even the trunk of the vehicle. How do we get it through here? Well, we have a firewall separating the engine and the passenger bay, so we need to find a hole in the firewall. That would be ideal, number one. We need to find where all our wiring harnesses here, because eventually they will go through to the fuse box in the vehicle. So if you know where your car's fuse box is in the passenger compartment, then you're going to have a good indication of where these wires are going in. Now my fuse box is here on the passenger side, right in the corner, so I'm going to assume there's going to be a hole in the firewall around this area. Now it's quite hard to see. You may need to remove some components. Generally, the bigger the car you have, the easier time you're going to have locating it. So I'm going to remove some of these components out of the way so we can get a better look at the hole through the firewall and see what we're working with here and see what other options we may have. Okay, so I've moved a few things out of the way, mainly the car battery there, so we can get a good look at how this goes through the firewall. Here's our main sort of electrical harness coming up and in. It looks like it's bolted on with two 10mm bolts. So we have a few choices. We can feed a wire up and through the grommet right here, or we can drill an entirely new hole through the firewall. Now that's going to be up to you. It's going to be personal preference, but it's going to depend on the year, make and model of your vehicle, which one you would like to do. If you are drilling a hole through the firewall, then I recommend using a step drill bit and then putting a rubber grommet around your hole so none of the insulation off the wires is going to chafe on your hole, and then you're going to get a short and then you're going to be in trouble. So if drilling a new hole, use a grommet, and always make sure there's nothing on the other side of your drill bit, any wires or anything like that. For our purposes, we're going to be wiring from the battery and then we're going to be going through to the inverter. So this looks like the quickest and safest path. We already have a hole, we don't need to bother with new holes. So I'm just going to remove this harness and see what our options are for feeding a new wire through. I can either feed it up through the bottom, or I can make a small incision in there and insert it through there, but the choice is down to you. We're going to look at the best possible option. So if we come inside the vehicle, let's take a little look on the other side of that connector here. So up through the passenger compartment here, and just looking up, we can see the incision right there. Okay, so there's where it comes into the vehicle here. There's not much room for our cable here. It's pretty tightly packed right there. So I might have to look at inserting something just through the inner wall of this rubber grommet here, but being careful not to sort of affect the outside part of the rubber grommet. And then I think we can feed our wire through here just fine. So it looks feasible without drilling a completely new hole, which is always good. Okay, so if you want to make an incision in this cap here, it's probably going to be the easiest way. I recommend unbolting it first. You don't want to just blindly stick a knife or whatever tool you have into here. You're going to risk damaging your wiring. It is not worth it. You're just going to destroy everything. So remove this and you can get easy access. And we're going to make a small hole, which I've done a little bit of already, and we're going to feed the wire through. Okay, so we see our positive cable going through our rubber grommet right there. Everything looks quite good, right? Whoa, wrong. No, that's terrible. Don't ever do that, because we should always use trunking or conduit when working with wires in automotive systems, even in the cabin of the car as well, not just under the hood. It protects all your cables from heat and everything else. We don't want to have this insulation melted through hot temperatures. We don't want to get gases in it, anything like that. Conduit is great, but this conduit is quite big, it's quite meaty. I have no idea how we're going to get such big conduit through this very tiny hole there. Well, you can also use some braid right here. This is heat resistance braid, and this heat resistance braid pretty much acts like the conduit as well. It's heat resistance. Typically you'll see it on computer power supplies or something like that, and it has a lower size profile than the thick meaty conduit right here. So this is going to be ideal for us feeding it through. So we're going to feed our wire into this right here, then we're going to feed them both through the rubber grommet together as one. So there's an easy way and a hard way of putting this braiding on. The easiest way is to just hold it with the end, bunch it up like that, and then it'll go on. Pretty easy when you know how, right? So we're going to feed this all the way over our segment of wire here, and then we're going to push it all through together. Okay, so now the wire has its clothes on, we're going to feed it through the rubber cap, ultimately through the firewall. Okay, so crawling up and inside the car, it looks like we're in business. Okay, so we have our positive wire here going to the battery positive, which is going to go ultimately into our inverter. Don't be afraid to pull enough through more than you need. We can always cut it down later, but it's very hard to build it back if you accidentally cut off too much. And now you can see the reason why we didn't really want to put crimp connectors on here, hoop terminals, whatever you're going to put on here before feeding it through, because we're working with very limited space and we don't want to make a bigger hole than necessary in our rubber cap. We want to make sure we separate the engine from the passenger with dirt, debris, heat and everything else. So now we can begin crimping these connectors for our inverter. But wait, what about the ground lead? Don't we need to thread another ground lead through here as well? What's going on with that? So we can quite happily thread another cable through here, a nice black one going to the battery negative, and then we're all done. But why even bother do that? The car is one giant grounding post. There's no need to buy extra cable, make our hole even bigger in the rubber cap. It's just unnecessary work. We can find a good ground anywhere on the chassis of the car, preferably internally, then our cable can be as short as possible without threading anything through the firewall. Okay, so if looking for a grounding point for our inverter, if we're not using the negative post on the battery, where the hell do we ground to? Well, let's look at where our inverter is going to be. I'm probably going to put my inverter right across here, potentially even there, but I think I'm going to have it here. So I'm going to look for a grounding post or a grounding point close to this area. There's no sense buying a super long cable to ground it very far away. It's just a waste of money and a waste of time. So let's look for a grounding post near here. If we come under here, there's a nice metal box here. There's a couple bolts there. I could easily slip a hoop terminal on there. But when looking for a ground, as the chassis of the car is one giant grounding post, we want to make sure we're actually grounding to the chassis of the car. If we look closely here, you can see a small little plastic washer behind here. So How do we know if this is a good ground if we have some plastic separating our metal from the chassis of the car? We don't. So we can test this with a multimeter, put one of the probes on the battery negative and the other probe on our potential grounding point and see if we have continuity. If we come across here, we can look around here. We could potentially remove plastic panels to check for grounding points. There's going to be a fair few grounding points in the car. It's just up to you to try and find them. If you can't possibly find one, or maybe you think you have found one like this right here, there's a nice area of the car right here. Well, this is not going to make a good grounding point because it has paint on here. We need bare metal, a bare metal surface. If this is the case, you can only find something which is painted. It's no problem, just get a drill bit and remove some of the paint here with a wire brush or something like that until we get a bare metal contact, and then we can attach it as a grounding point for the inverter. But we cannot make a good grounding point if there's paint in the way. It has to be a bare metal contact. So any multimeter is going to work for this. On one end we have our negative right here, and this is just connected to the negative terminal on the battery, so we're going to be 100% sure this has a very good ground. Okay, so there's two ways to do a continuity test depending on what multimeter you have. The easiest way is to use this little symbol here, these three wavy lines. There's the setting right there, and when you make a connection with the other probe, it's going to make a beep like that. Now, some of the cheap multimeters don't have this setting. Don't worry, you can use this omega sign right here, which is resistance in ohms, and you'll see a similar effect, but instead you'll see this number slowly going down towards 0. So you see how the number creeps down, and that is another way you can check for continuity. But the point is, we're looking for a good ground for our inverter. So when it beeps, essentially we have potentially a good grounding point. So let's look at this box here. It's beeping. Check the stud itself. Good. How about this nut hiding all the way up here? Not good. So this is why it's important to know what to check and if you have a good grounding point. How about the trim of the car right here? You see absolutely no sound on the multimeter here. So why is that? Well, we need to contact a bare metal. You see this is a painted surface. It's affecting the connection. Now this is very important because if you have a grounding point and there's paint on there, or there's a plastic piece hiding behind what looks like a good conductor or a good grounding point, you can see there's a plastic washer just there. There's a plastic bit of trim hiding behind that one. This could be separating what you think is a good grounding point to almost nothing at all. Then we're going to run into, whoa, a very big issue really. So this is why it's very important to check with a simple multimeter. If you don't have any options and you only have a painted area, it's no problem. Take a wire brush or a drill with a wire brush drill bit and remove some of the paint, get a good grounding point, and then you can spray it over with some clear coat to protect it from corrosion afterwards. No problem at all. But don't be afraid to remove some plastic trim or some carpet in search for a good grounding point. It's very important. So one thing I'm going to mention before putting everything back here is if your hole is slightly too big or you're worried about things getting in here, it is supposed to be a protective barrier, then you can use some silicone or something like that. Regular old silicone is going to work just fine. Put a little on the inside here, so behind the rubber cap, and that's going to keep everything sealed and you're going to have no problems with that. Okay, so if you decided to use braid here instead of conduit, no problem at all. There is a little tip I want to leave you with. So we're just going to cut this a tiny bit longer than our cable right here, so I'm going to cut it there. And in the future, if you cut this at any point, always burn the edges. Otherwise, this is going to slowly strip all the way back and it's going to end up being absolutely useless. So it's like when working with nylon and things like that. So just get a lighter, go over the end a little bit, and then that's going to seal it in. So it's going to end up looking a little something like that. It may look pretty, but it's going to prevent further damage along the line. And every time you cut this, always burn the end. Okay, and now our wire is exposed. We need to crimp and connect these ends to whatever connector you want to use. I recommend hoop connectors because our inverter has those sockets. Also our terminals here, you can easily slip a hoop onto any of these. It's going to be the easiest way for us. And if you want to learn how to do this properly with proper vacuum tubing, proper crimp tools and everything else. I'll link a video in the description below. You can check it out. I go through the entire process. I don't want to pad out this video out too much, but this will teach you everything you need to know about crimping any size of electrical cable for a vehicle. So just a little caveat, when choosing your connector type, make sure it works for you. All of our circumstances are going to be different, but when considering this, take a look at your battery terminals. You might have something like this and you might think, oh, how does a hoop connector go onto here? There's no, post or anything like that. So then you can switch these out with something like this, and you can see there's a little bit of a post there. We can easily put a hoop connector on there. Make note of the width of this as well. This is 8mm, so your hoop connectors should also have an 8mm hole, which is the empty slot right there. And if you even don't have room on your terminals, you can see this one is quite shallow. You can also upgrade these to something a little taller as well, so you can fit multiple hoops onto here. Okay, let's get going. Okay, so a big question is, should I wire to the battery directly, or shall I run the wires all the way to the alternator? After all, the alternator is responsible for charging the battery. Where am I running my inverter to? Well, you should always connect your cables to the battery. The battery acts as a buffer and smooths out voltage spikes and protects your inverter and the car's electronics from fluctuations caused by the alternator. Direct to alternator wiring is risky. Alternators can produce voltage spikes and aren't designed to handle direct accessory loads. Connecting your inverter directly here could lead to damage or erratic behavior. So now we know how to crimp and create our own beautiful connections. Let's talk about fusing. So at the start of the video, I told you all the reasons why you shouldn't hook up an inverter to the fuse box, so we're bypassing it completely. So this is why fuses are important. And I'm not talking about these fuses. I'm talking about these fuses. Now the fuse we're going to be using to protect this circuit is called an ANL fuse. It's just a bigger, fancier version of that smaller fuse I just showed you a few seconds ago. This is going to sit on our positive cable from battery positive to our inverter. Now if anything happens to our circuit, this cable, we get a short, some of the insulation comes away and the metal touches something inside that rubber grommet, anything happens, then this fuse is going to blow and we're going to protect our circuit, preventing fires, smoking, melted wires, and any other disaster that may happen. So because we sized the fuse to protect the wiring in our circuit, we want to put this as close to the battery positive terminal as possible, so between ideally 6 to 12 inches. And in order to get a good placement for this, I'm going to put the battery back in and figure out a great spot to put this fuse, and then with that information I can crimp and cut the rest of this wire to place our inline fuse in position. So if anything bad happens on our circuit, the fuse will blow, and the only piece of wire which is unprotected is the tiny segment of wire between here and the battery positive terminal, which is why we want to make this as short as possible. Okay, so I've put all this hardware back together so we can get a realistic look of how this is going to look when it's done. We have our cable coming out of there. I've just loosely put it behind here, and then it's going to sort of go around here and hopefully sort of in that position. So looking at this, where is a good position for my fuse? The fuse is quite meaty. This is a very small car. Your circumstances will be different as well. If I put the fuse in this huge empty section right there, that will be great for the fuse. I can maybe mount it here, but then all of this wire here will be unprotected, which is around 18 inches give or take. That is option number one. Option number two is I could put the fuse in this tiny little gap here. It might be a little fiddly to set it up, but once it's up and running we can connect it here, and that way only this tiny bit is unprotected there. So we have a couple options here, but it's important to put everything in place so you can route your cable correctly. You can crimp it without crimping too much, and you'll have a realistic expectation of where everything's going to be before you start chopping cables and making them potentially too short. Okay, so I think I've decided I'm going to put mine around here. There's a nice mounting point here, it just makes sense. I've measured everything, which is around 10-11 inches of unprotected cable, which I'm pretty happy with. As long as it's less than around 12, it should be fine. And the other reason is there's not much space here, and if I mount quite a large fuse in here, then I'm going to lose access to change out my headlights quite easily. It's also near the coolant refill port, so I could potentially get coolant in there when refilling and potentially corrode anything. I think this is the best solution for my circumstances, but the choice is yours. Every car is different. Okay, now let's start crimping some connectors and getting this fuse into place. Okay, so I've just connected the positive terminal here on the battery. I can tidy up the placement later, but the point is I want to test this before I get everything settled into place. If something goes wrong, then it's more things to undo. But right now we're getting power to the inverter. Okay, so I'm pretty happy with that now. That's gonna look great just there. I'm just gonna finish up the last connection. Okay, looking good. So before I put the battery back in, I'm gonna secure the cable with some zip ties. The last thing you want is a loose wire or a loose fuse box flapping around while you're driving. So I'm gonna tie this down and then we're gonna put the battery back in. Okay, so that's our last connection secured right there. By the way, if you're still having trouble with this braid, it's just not working out for you, then you can just secure the end with some Tessa tape. I highly recommend to use this on car electronics. You can actually use it in place of conduit in some places. And what you can do is just sort of tidy this end up right here. That will work fine. A lot of people do this. Just a little tip there. So there, looks a little better, doesn't it? Alright, let's connect this up to pretty much everything else on our positive terminal here. You might have to fight for a bit of space. This is where pretty much everything comes into our battery here. As I mentioned before, you can upgrade the post so you can slip the terminal on, no problem. Your configuration is 100% going to be different. Just work with what you have. Now our last piece of the puzzle is the ground wire. We talked all about the ground wire earlier, but what we didn't talk about is we could easily use something like this. We know it's gauged correctly because it came with the inverter. The wire is already sized based on the current draw of the inverter by the manufacturer. So if this cable reaches where you want to ground it to, then there is no harm using it. I'd recommend chopping off this end and then re-crimping it with another hoop connector on the other end, and then you have yourself a ground wire, saving yourself potentially $10 in the process. Okay, so I'm just going to remove the paint off the grounding point for our negative terminal. Okay, so all the paint has been removed off there. We have a nice solid grounding point on bare metal. I'm pretty happy with that. Let's hook up the ground. Okay, so time for the ground cable. Pretty much rinse and repeat. Gonna put on our hoop connectors and hook it all up. Okay, so I raided my toolbox. I found this bolt and a couple washers. That's gonna give our ground clamp a good securing. Okay, so that's the ground secured. So we just slip our braid on now, trim it to length, and then we're going to put our hoop terminal on, and then we're almost ready to go. Okay, so just going to tidy it up with some zip ties. Okay, and that is the wiring job pretty much complete, all tidy, hooked up. The last thing we're going to do now is test it. For the inverter, I mounted it on the carpet here, and in order to do that, I just used one side of some Velcro right here, the hooks only. I stuck it onto the bottom of the inverter, and it is very solid. It's not going to move anywhere, so pretty happy with that. Let's test it out. Okay, so before I put everything back together again, let's give it its official test. I haven't tried it yet. I have no idea if it's going to work. It should work, but we'll see. So let's press it. That looks promising, doesn't it? Look at that. Wow. So this doesn't show up very well on camera. It just says the battery voltage 12.7 and AC voltage 229, so 230 because we're in the UK, we're in Europe. Look at these dirty European sockets. But for our American friends, we do have a multi-adapter on the side as well. So whether you have a modified sine wave inverter like this one or a pure sine wave inverter, it really doesn't matter. The principle is, as long as you've laid the cables, and if you went with a lower gauge to future-proof yourself, you can easily upgrade in the future. It is no problem at all. It's down to personal preference. So something very important, if you're planning on installing an inverter, an amp, or something that's going to use a lot of current, you're drawing a lot of current, then I recommend installing the big three. This means replacing the big three cables in your car's electrical system, and this way you know that your car will be able to handle the load no matter the year. This involves replacing the cable between the alternator and the positive terminal of your battery, the negative terminal and the chassis, and also the alternator ground, but ultimately the engine block to the chassis frame as well. Upgrading these three components will ensure you have a perfectly healthy electrical system, putting less stress and load on your alternator. And if you want to learn all about the big three, I'll link a video in the description below. Let's continue. So I hope this video helped you install your own inverter into your car, truck, camper van, RV, or even your garden shed, wherever you want to install it. Like and subscribe. I make videos like this all the time, and more videos like this coming soon. Take care, guys.